One particular technique that's sometimes used in training generative AI models is called adversarial networks. Remember that AI models get their magic from what they have learned, how they have been trained. Whatever the model does or generates comes out of that learning. So creating a better model really comes down to creating one that is good at learning and that has been trained well for the results you're looking to achieve. The adversarial network method employs two models. The first is your main generative AI model, the one you're working to train. The second model is the adversarial network called a discriminator model. It helps you to do that training effectively by scoring how good the results are from the first model and then feeding that score back into that model. Generally, these adversarial networks have been used to increase the fidelity of outputs from the generative model, i.e. how human-like those outputs are. Westworld fans will appreciate the term testing for fidelity here. The discriminator model is trained to classify its inputs as either human-generated or AI-generated. It's trained on lots and lots of generative model output and told, this is AI, and then trained on lots and lots of human-written content from the web or elsewhere and told, this is human. And it learns to pick up on any telltale signals of which is exactly what these models are great at doing. Then the discriminator uses what it's learned to score new outputs from the generative model. The score is most likely not a simple one or the other classification, but rather a confidence level, such as 90% confidence this is human-generated, 10% confidence it's AI, for example. If a result comes back close to 50-50 on a given input, it means the discriminator just can't tell. If the discriminator model has high confidence that the generative output was AI-generated, then it scores that output low and feeds that score back to the generative model. If it can't tell whether it was AI-generated or not, then it scores it higher. And thus the generative AI model gets better and better at seeming human-like in what it generates. Fidelity. Basically, the discriminator is trying to catch the generator, and the generator is trying to fool the discriminator, which is why this setup is referred to as adversarial. The models are helping each other improve by playing against each other in a mutually reinforcing game. As you can imagine, the adversarial model could be used for scoring things other than fidelity. For instance, given the outcry we're hearing about the number of falsehoods and hallucinations that popular large language models are producing, we can easily imagine an adversarial model that fact-checks the output of the generative model and dings outputs that are false, gives them a lower score, or perhaps ones that are racist or evil in some other way. Models are simply the products of their training, and so they can be trained to generate outputs that fit any set of criteria, which perhaps raises some interesting philosophical or ethical questions about what are appropriate things to train models for. Now, discriminator models can also be used for more than just helping train the generative model. They can be used to catch generative AI content in the wild. There's understandably a great deal of concern that people will misuse or overuse generative models in school and in content creation generally. And already some folks have announced models that can detect whether given content is AI generated or human generated. Those models are discriminator models, like we've been talking about. So the adversarial game between the generative models and the discriminator models continues out in the real world. I believe that inevitably leads to some kind of arms race of which models can fool other models and which models can catch other models. And both the generative models and the discriminator models are just going to get better and better because of that mutual reinforcement between them. So that in time, it's likely that only the very best discriminators can catch really good generative models, and only the very best generators can fool really good discriminators. Should be interesting to see how that plays out. Thanks, everyone. That's my thought for now. I'll be back again soon with more. Take care.